Okay, Coroneos 100 integrals, number 62. All right, so for this question here, we need to integrate 9 minus x squared to the power of half. Now, this is unfortunately that not a definite integrals here. If you look at the function itself, it's just a square root of 9 minus x squared, which is a kind of a semicircle. And if it's definite integrals going from -3 to +3, so we should be able to just use very simple, finding the area of a semicircle to, evaluate this definite integral. However, this question is not a definite integral here. So in order for us to do this question, we need to use some trig substitution to help us. All right, so first step, let's change that into square root of 9 minus x squared dx. And you can let x equal to 3 cosine or sine function. It doesn't really matter which one. It's really up to you, which one you feel like it's easier for you to do the question. I'm just going to let x equal to sine 3 sine theta here. All right, so I'm going to prepare for that. So dx is equal to 3 cosine theta d theta. Now we can start to do the substitution. So that's 9 minus 9 sine squared theta multiplied by dx, which is 3 cos theta d theta. Okay. All right, so now what's inside the square root is going to be 9 cosine squared theta, and we'll still multiply by 3 cosine theta d theta here. All right, so once you've got this, we can remove the square root, all right, so that we end up with 3 cos theta times by another 3 cos theta, and we end up with just cos squared theta that we need to integrate. So cos squared theta to integrate is actually pretty easy. We use the double angle formula, so we can change that into 9/2, which is like a half, and that becomes half 1 plus cosine 2 theta here, d theta. And now from here, we should be able to just integrate. Okay. Okay, but you need to remember this. We still haven't finished the question. We need to find out what is the value of theta here. So remember from previously, we let x equal to 3 cos sine theta, I think. 3 sine theta. So based on these values, sine theta is equal to x over 3. So if we simply draw a right angle triangle, try to find out what is the ratio for that. If that angle is equal to theta, opposite side is equal to x, adjacent side is equal to, the hypotenuse is equal to 3. So therefore the adjacent side is just going to be 9 minus x squared and square root. All right, so once this is down, then the next step we can do is we can do a substitution back inside. But before we do that, and there's there's a double angle there. So I guess maybe what we can do is we can expand and simplify. That gives you sine theta cos theta plus c here. Okay. All right, so what I did here is the double angle formula, 2 sine theta cos theta. So these two actually cancel with the half. So these two cancels out, and you still have 9/2 in the front. All right, so now we can just use our triangle. We know what sine theta equals to. Sine theta is equal to x on 3, so times by x on 3. Now we need to work out what is cosine theta based on this diagram. Cos theta is equal to square root of 9 minus x squared over 3 plus c. Okay, so I think that's it. But if you want to simplify it a bit further, you can. So we can take a few values out. But if you look at this, that's 9, that 3, cancel with the 3 here. So if we just factorize the half outside, we should end up with just equal to 9 theta. Oh, by the way, what is theta equals to? I still haven't replaced the theta here. I still have to replace the theta. All right, so for theta, that is equal to sine inverse x on 3. So this is actually quite important. Almost forgot about to replacing the theta back into the x plus x square root of 9 minus x squared plus c. Okay, so that's how you end up doing this question here. So we simply use a trig substitution to work out the answer, but most importantly is once you get the result here, we still need to replace the theta by the value of the x by using a right angle triangle and also the inverse trig here. Okay, all right, thanks for watching.